All right, number one, the balanced equation, reaction of magnesium. So this is one on section 11.2. I have some magnesium. It's going to combine with some oxygen. Oxygen is diatomic, and we know that because we've memorized it. It's going to produce some magnesium oxide, so magnesium oxide. To make sure I have the right ratio for magnesium oxide, I'm going to crisscross and balance the charges. So I have my magnesium. That's group 2. It has a 2 plus charge. Oxygen is group 6. He wants to get to 8. So if I'm at 6, I want to get to 8. I need 2 more. Crisscross the charges. And then reduce that down. 2 to 2 is the same as 1 to 1. So that's my formula for magnesium oxide. All right, from there, let's get rid of all this now. Now that I know I have my right formula, now I can balance it. Same thing on the left that I have on the right. So I have 2 oxygens. Actually, before I do any balancing, I'm just going to close those guys in. Now that I have the right formulas, do not change the subscripts, but instead change the coefficients of the number in front. So on the left, I have 2 oxygens going in. I need 2 going out. So I'm going to double my whole compound. Now I have 2 magnesiums. So over here, I need 2 magnesiums. And now that equation is balanced. Number 2. I have some aluminum reacting with fluorine. Fluorine is diatomic. That means there's always 2 in a pure substance. So now we don't get a product, we have to figure it out. Well, if we have 2 individual things, they must combine in a combination reaction. And to figure out the right formula for how they combine, aluminum's group 3, fluorine's group 7. If I'm in group 7 to get to 8, I need 1 more. And if I crisscross my charges, my 3 goes down there, my 1 goes down there. So AlF3. Now that I have my proper ratios, I'm going to box them in. After I figure out the right ratios, do not change the subscripts. Now I change the coefficients. Okay, so I have 3 fluorines on the right and 2 on the left. So my least common multiple is 6. So I need 6 fluorines on each side. So a 3 in front, 3 times 2 is 6. And 2 times 3 is 6. But now I have 2 aluminums. I need 2 over there. And now I have a balanced equation. Number 3. So I'm going to decompose something. I'm going to decompose some potassium, not phosphorus. I'm going to decompose some potassium chlorate. Chlorate is a polyatomic. I know it's a polyatomic because it ends in ATE. So I go and I look that up. And it tells me my formula is 1 minus, or my formula is ClO3. My charge is 1 minus, and potassium is group 1, so it has 1 charge. Okay, so if I crisscross the charges, 1 to each, that one goes there, that one goes there. So there's my formula, KClO3. Says it's going to decompose. And it's going to make some oxygen gas. Oxygen gas is diatomic, so I pair it. And I'm going to get some potassium chloride. So potassium chloride is just chlorine as an ion. And to make sure I have the right formula for KCl, K is group 1, chlorine is group 7. It wants to get to 8, so it gains 1. 7 plus 1 is 8. I crisscross them into a 1-to-1 ratio. All right, from there, now that I know my right ionic formula, now that I've figured that out and that out, I'm going to balance my equation. So I cannot change my subscripts. I'm going to box that in. That's one big compound. Box that guy in. I'm going to box that guy in. Now all I can do is change the coefficients, the number in front. So just to summarize, I have one potassium, I have one chlorine, and I have 3 oxygens. Over on this side, I'm just going to rewrite the same elements in the same order. Single potassium, single chlorine, 2 oxygens. Alright, so there's my 3 and my 2 again. I need the least common multiple of those guys, which of course is 6. So I need 6 oxygens on each side. So, to accomplish that, I'm going to double that whole compound. So now I have 2 times K, 2 Ks. I have 2 times Cl, 2 Cls, and I have 2 times 3 oxygens. And on my other side, I need 3 oxygens. So now I have 3 times 2 is 6. Now I have 2 Ks, 2 potassiums over here. I need 2 on the right. So I need to double that. Now I have 2 Ks. And I need 2 Cls. My left side equals my right side. So now that's balanced. Number 4. Let's see. I have hydrochloric acid, HCl. You don't have to memorize that. I will give you all of the acids. I'm going to throw some calcium metal in there. When they react, I'm going to get some hydrogen gas. Hydrogen is diatomic. And I'm going to get some calcium chloride. Okay, calcium chloride is an ionic compound. So to figure out the right ratio for that, calcium is group 2, so it has a 2 charge. Chlorine is group 7. It wants to get to 8, so 7 plus 1 is 8. It gains 1 electron. I crisscross the charges. So my 2 goes down here, my 1 goes down there. Now that I have the proper ionic compounds, I'm going to box in my formulas because I don't want to change them anymore. That's set. Now I'm just going to balance it. Well, I have 2 hydrogens over here. I need 2 on the left side. So to get 2 on the left side, I put a 2 in front of there. Now I have 2 H's. I have 2 Cl's. 2 Cl's over there. Everybody's balanced. Number 5. I'm combusting some propane. It tells me my fuel. Anytime you have a combustion reaction, you have to memorize the other parts. Every combustion reaction, to burn something, we need oxygen. When we burn something, we get 2 things. The 2 things that we expel out of our mouth: carbon dioxide and water. Those ones in black are characteristic of every combination, every combustion reaction. Alright, I'm going to box those in. Combustion reactions can be a little tricky, trial and error. But we'll go through this one. This one's not too hard. I'm just going to list out what I have on each side. Okay, I have 3 carbons, 8 hydrogens, 2 oxygens. On the right side, I have 1 carbon, 3 oxygens, because I have 2 plus 1, and 2 hydrogens. Okay, most of the time, if not always, it's good to start with carbon. I have 3 on the left, I need 3 on the right. So I'm going to add a coefficient there. Okay, before I do the oxygens, I'll go to hydrogens. I need 8. So I have 8 on the left, I need 8 on the right. So to get 8 over here, multiply by 4. And then my oxygens, well, I have 4 here, plus my 3 times 2 is 6, so 4 plus 6, I have 10. Okay, my carbons over here are good, my hydrogen's balanced. I just need to fix my oxygen. I have 10 over here. I need 10 over on the left side. So a 5 in front of there. 5 times 2 is 10. And now that's balanced. All right, number 6. I have some iron 3 chloride. The 3 is the charge. It tells me that. Chlorine's group 7. It's going to gain 1 to get to 8. And so if I crisscross those, my 3 goes down there. It's going to react with sodium hydroxide. So sodium is an element. Hydroxide is that polyatomic we should all memorize. If not, you can look it up. Sodium's group 1. Okay, crisscross the charges. So that's going to be probably a double replacement reaction. And it's going to tell me my products. Iron 3 hydroxide. So again, I got my iron, tells me my charge. My hydroxide, it's always a charge of 1 minus. That's a polyatomic, we just look it up. And I'm going to crisscross the charges. My 3 goes down there, my 1 goes down there. And I'm going to get some sodium chloride. Alright, my sodium, group 1. My chlorine is group 7, so it has a 1 minus charge. I crisscross them. And there's that. Okay, 3 chlorines on the left. I need 3 on the right. I'm just going to box this in. Put a 3 in front of there. That gives me 3 sodiums on the right. So I need 3 on the left. And that's going to balance everything out.